So here's where we left off last time in section 7.5. We had talked about these inverse trig functions, inverse sine, inverse cosine. Remember, inverse can be written as arc. So this was asking us to find the sine of the angle whose tangent is 4/3 minus the angle whose cosine is 12/13. And here's what we recognized. First of all, I can take my triangle, draw a right triangle, and I can put the ratios on there for a tangent that would be 4/3. The problem is I can find the other side using Pythagorean Theorem, but I have no idea what the angle is because that's not one of my special right triangles, like a 30-60-90 or a 45-45-90. So even though we could come up with what the ratios were on the triangle, we had to have another way to work this problem out. And that's when we recognized that since we're looking for an angle, that's what arctan means, this would be the same thing as thinking of the sine of angle A minus angle B, which fits our sum or difference properties. And using those sum and difference properties, where we think of the arctan of 4/3 being angle A and the arc cosine of 12/13 being angle B, then we rewrote using our identity, which came from here, okay, using the minus sign. And then we went back and we replaced, using our triangle, what these ratios would be. So the sine of angle A, coming out of this triangle, sine was opposite over hypotenuse, 4/5. And then we multiplied it times the cosine of angle B. So coming out of this triangle, that was 12/13. And after we made those replacements, we said we need to do a little cleanup. Now, did you guys finish it, or do we need to finish it together? Let's find out if your answer is right. So this became 48 over, how much was 13 times 5? 65. Minus 3 times 5 was 15/65. So what does that end up being?
30.
And that does not reduce down, does it? That's my answer. That's it. Okay. Now, let's do this one, and then we're going to move into lesson 7.6. So this is asking for the sine of 2 times the angle whose cotangent is -5. Okay, don't get lost in the words. Instead, let's kind of think about this a little bit. Any ideas on what we could do? Anytime I see arc something, what does this mean I'm actually looking for? Am I looking for a ratio, or am I looking for an angle? I heard somebody say it. Angle, yeah. If it's got arc, or you see cosine with the little -1 to show its inverse cosine, that means I'm looking for an angle measure. Couldn't I think of this as the sine of 2 times maybe A? If the arc cotangent of -5, I think of that as, I know it's an angle, and I'll just call it angle A. Now, if I think of it that way, do I have a replacement for the sine of 2 times an angle? Yes, I could look on my double angle formulas, which show up. There's the half angle. It's on the bottom. Thank you. Right there. And the sine of 2 times an angle is 2 times the sine of that angle times the cosine of that angle. So I can replace this with 2 times the sine of angle A times the cosine of angle A. Now the problem is I got to figure out what these values are if I know that the angle has a cotangent ratio of -5. So how am I going to figure out what the sine and the cosine would be that go with that? Draw a triangle. Excellent. So I'm going to draw a right triangle. And technically, since the cotangent is a negative value, which quadrant do you think I need to be in? Okay, remember with cotangent, we had said it's either got to be 1 and 2 or 1 and 4, and we pay attention to where the vertical asymptote would be on the cotangent, and it is going to mean that it's at 0 and at pi, so I'm restricted to quadrant 1 and 2, so good job. If we were to, let me just do it this way. Sketch this, we put this in quadrant 2. All right, I'm thinking of this as angle A. So the angle whose cotangent is -5, cotangent is what over what? I could think of it as cosine over. Okay, adjacent over opposite. So that's going to be a -5 over 1, right? And what will I need to find if I'm going to have to come up with a ratio for the sine and the cosine? The hypotenuse. And I can use what? Pythagorean Theorem. So you guys calculate that and tell me what that hypotenuse length is. Y'all agree with Elizabeth? Square root of 26? I hope so, because if I take -5 and square it and I add 1 squared, that's going to give me my hypotenuse squared. And so 26 equals the hypotenuse squared. That would mean C is the square root of 26. So far, so good? All right, let's substitute. The sine for this triangle would be what ratio? 1 over the square root of 26. And what would be the cosine for this triangle? -5 over the square root of 26. Excuse me. And that 2, I can think of as 2 over 1. All right, let's multiply this together. If I go straight across, what do I get in the numerator? And is it a -10? And what is the square root of 26 times the square root of 26? 26. I'm squaring a square root. That means that the square root cancels out. And can I reduce down -10 over 26?
Yes.
To what?
-5 over 13.
Awesome. That is it. -5 over 13. Now, the math is not necessarily, or the arithmetic is not necessarily that hard on that. It's the, can you recognize that you're going to have to make that replacement when you see arc sine or arc cotangent or arc cosine? Drawing your triangle to figure out what all those side lengths would be, and then either pulling in something like a double angle or a sum or difference, possibly a half angle, hopefully not, because these others are easier to work with. All right, are we good?
Okay, can you just explain me just like one more time how you went, or you got to sine and you 2 times A?
This part?
Yes.
Okay, because I know I was looking for the sine of, and in parentheses, it's 2 times the angle whose cotangent is -5. So that told me this is an angle. And since I'm looking for an angle measure, rather than have something that looks real messy like this, I could just make angle A equal this arc cotangent of -5. And if I replace it like that, because this means I'm looking for an angle, so I'm just going to call it angle A, then that's what told me I've got a double angle identity I can use, and I replace it with this off the double identity sheet. Okay? All right. Let's not worry about the rest of what's in 7.5, and let's look at 7.6. Now we're going to try to solve some trig equations. All right, these are not the identities where it's already an equation that we're trying to get the left side to equal the right. These are going to be set up where we're going to be looking for, most of the time, the angle measure that would make this true. Okay, so this will involve a fair amount of algebra, and then we'll have to see when we need to maybe apply some of our trig identities or properties in order to get this simplified. So this says solve the equation 3 times the tangent of angle Q minus the square root of 3 equals 0. And the first thing we'll do is solve it over the interval from 0 to 360. So if we were looking at one complete revolution, what angle measures in there would make this a true equation? Does that part make sense as far as what we're looking for? Okay. Now, looking at it, I have no idea. I'm going to have to work with this a little bit algebraically. So just think about the tangent of angle Q. If this were an x, if it were 3 times x minus the square root of 3 equals 0, what would you do to try to get to where you could solve for x?
Move the square root.
That is exactly right. We're going to do the same thing. You're just kind of thinking of this tangent of Q as being my x value I'm looking for. So let's add the square root of 3 to each side. So 3 times the tangent of angle Q is equal to the square root of 3. Now, what could you do next?
Divide 3.
Yeah, divide by 3. Okay, so now it says the tangent of angle Q is equal to the square root of 3 over 3. Okay, now, is there anything about the square root of 3 over 3 that sort of looks familiar? What does this look like? Maybe this was rationalized, which before it was rationalized, it would have been what? Okay, very good. The tangent of angle Q could be thought of as 1 over the square root of 3, because when it was rationalized, that's what turned it into this. Now, ideas. How could we figure out what angle Q would be?
Could it be a triangle of 60, 30, 90?
It looks like this had to come out of a 30, 60, 90, and I'm figuring out which angles between 0 and 360 would give me this ratio. So here's what Elizabeth is saying, all right? And basically, here's what we're doing. We're taking the arc tangent of each side. You don't necessarily have to write this down, but I just want to show you this would be technically what we're really doing. Because if I take the arc tangent of the tangent, this side just becomes what? This is saying that I want to find the angle whose tangent is the tangent of angle Q. This just solves for Q. The arc tangent cancels out the tangent, just like a square would cancel out a square root, okay? This is just saying we are looking for the angle whose tangent ratio is 1 over the square root of 3. And I think even without doing the arctan on each side, we all understand that, okay? I'm just showing you if you were to write all the notation down, technically this is how we're solving for the angle measure. Now, Elizabeth said she thinks it's going to be a 30, 60, 90. And which quadrants would tangent be positive in? Because this is a positive ratio. 1 and 3. So if I were to draw this in the first quadrant, and this is my angle Q, tangent is what over what? Opposite over adjacent. So that would mean 1 over the square root of 3, right? And that would make the hypotenuse 2. So tell me, if I'm in quadrant 1, what is angle Q? 30 degrees. Now, if I go to quadrant 4, and this is a 30-degree angle in quadrant 4, so that I would have a -1 here, and a negative square root of 3 here, and a negative divided by a negative gives me back a positive, what would this angle be? It's 30 degrees in the third quadrant, but what would be the actual angle measure to get there? 210, because you got to go 180 to get here, plus another 30. Those are the two angle measures in degrees, and because they gave us our interval in degrees, we'll give our answer in degrees that would make this true.
So we have to do 2.
Because it says over that interval. So any values that would make it true in that interval. And it should be 2, because you're going to have 2 quadrants that give you positive values and 2 quadrants that give you negative values. Don't worry about the for all solutions. It simply means that you would have to add 180 degrees as many times as you want to get multiples. As long as you can tell me over the one interval, that'll be fine, okay? All right, so in terms of the algebra part of this, is everybody good? Excellent, all right. Now, let's look at this one. And it says, solve the cosine of angle Q times the cotangent of angle Q is equal to the negative cosine of angle Q. And we're going to stay in the same interval from 0 to 360. So, ideas, if we're starting with this, I don't think I have a clue what I can do with it if I leave it in that form. So what would we maybe want to do first?
Could you do the reciprocal cotangent?
Well, I'm going to give you a suggestion. Look at what they have in parentheses. It says zero factor property. Do you remember what the zero factor property is from algebra? Like if you had a quadratic equation, you want to make sure you get everything on one side and set it equal to 0, because if I could get it factored and I have this times this equals 0, what do I know that this or this has to be so that when I multiply, I get 0? One of them has to be 0, right? That's how we solve whenever we factor. We got to make sure it's set equal to 0 first. So there you go. Why don't we add cosine of angle Q to both sides? And we'll get the cosine of angle Q times the cotangent of angle Q, and then we'll add the cosine of angle Q to both sides, which will make it cancel out over here and give us 0. Does that make sense? We're adding the cosine of angle Q to both sides. Okay. Now, my suggestion was, if we can get this to factor, remember this times this equals 0 means either this or the other factor would have to equal 0 for this to be true. So look at this. Do you see first of all, how many terms are here? 2. Terms are always separated by plus signs or minus signs. So do I have a common factor? There you go. I can factor out cosine of angle Q as a common factor. If I do that, this is like backwards distributive property. Cosine of angle Q times what gives me back this first term? Cotangent of Q. Good. Don't forget the plus sign. And to get the second term, cosine of angle Q times what gives me the cosine of angle Q? 1. Okay, does that make sense? Honestly, that's the hard part, all right? You got to recognize that if I don't have any idea what I can do with it like it is, let's try to get everything on one side, especially if I see I would have a common factor, and let's get the thing factored. Because now that it's equal to 0, the only way this is true is if what equals 0? Either, what's one of my factors? My common factor here, cosine of angle Q has to equal 0, or what else equals 0? Cotangent of angle Q plus 1 would equal 0. Are you with me so far? Okay, so let me explain this one more time. This did not say that you're trying, like if we were back in 7172, it would have said to verify the identity. In other words, we would have tried to rewrite this side to make it look like that. That's not what this said. This said we're going to solve it. In other words, you got to tell me what angle Q needs to be to make this true. So when it says solve, one of the strategies will be, if I recognize that I would have a common factor, if I get these on the same side, I'm going to want to move it all to one side, set it equal to 0, and then factor out my common factor. Okay? So the way it's backwards distributive property. It's the same thing as if, and I'll put this on the paper so you guys can see. It's the same thing as if you had 3x plus 18 equals 0. Okay? If I asked you to factor that, what would you notice? Do you have you got a common factor of how much? 3. So if I write down a 3 and I open my parentheses, what would go inside when this is factored? Very good, because the whole idea is, if I am doing backwards distributive property, if I get this factored right, it means this times this should equal my first term, and this times this should equal my second term. Correct? That's all we've done here, is I've looked for the common factor, I write it down, I open a parentheses, and I say this times what gives me back this first term, everything that occurs before the plus sign. And then I put the plus sign, and this times what gives me back that. So that's how we got it factored. Now, I have to recognize if this times this equals 0, either my common factor, which was cosine of angle Q, has to equal 0, or my parentheses has to equal 0. Okay, so far so good now? Good deal. Okay. Can you tell me between 0 and 360, when would the cosine give me a ratio of 0? What would probably be the easiest way for me to figure that one out? There you go. I can use holla, right? So cosine for 0, 90, 180, 270, and 360 starts high, right? Holla. And where would I get a value of 0? At 90 and at 270, okay? So here's what I'm finding. I want to find all of the values for the angle measure that would make this true. So angle Q can be, and I'll open up braces, and inside I'm going to put 90 degrees and 270 degrees from this. Do I have some other angles that might occur as well? I haven't solved this yet. So what do I need to do to solve this? Subtract 1. Very good. So what I'm looking for is where the cotangent has a ratio of -1. Now, cotangent is not cosine. It's not sine, but it would be what? Cosine over sine. Okay, so I need to know, where would cotangent have a ratio of -1? So I could either do holla and a holla and figure out where I would get a -1 for a ratio, or is there another way, maybe using triangles, we could figure this out? Is that one of my special angles? Because what kind of angle gives me a cotangent ratio of 1? Either positive or negative. It comes from a 45, 45, 90, right? Now it's up to you which way you want to do this. If I think about it as using 45, 45, 90, which quadrants would cotangent be negative? 2 and 4. There you go. So I know that's got to be 45 here. That's got to be 45 here. And my adjacent over opposite, this one is -1 over +1. This one is +1 over -1. So all I have to do is figure out what these angle measures are. If I travel over to a 45-degree reference angle in the second quadrant, that's how many degrees? 135, because it's 90 plus 45 more. What would be this angle measure here? Because I would go 270 plus 45 more, and that would be 315. I've actually got 4 different angle measures that would make this true.
Could you show how if like we didn't do the triangle, instead we went through holla and a holla? Like how would we do that?
Well, the issue on an angle measure of 0, 1, or -1, if you're talking cosine or sine, means you're on an axis. So you can draw a triangle, but you'd have to squeeze it up to an axis, and you got to figure out which axis you're squeezing up to if you want to use the triangles. That's why holla and a holla, to me, is easier if it's a 0, 90, 180, 270, 360 angle, or if I know the ratio is 0, 1, or -1. That tells me I'm on an axis. Did that sort of answer your question or not?
Yeah.
Okay, because yeah, if I'm on an axis, I don't really have a triangle. I have to picture the triangle squeezing up on itself.
So is it better when we're solving for cosine, it's better to do a triangle or to draw the triangles instead of doing a holla?
Say that one more time. If you're doing cotangent, I would say it, if you recognize, hey, wait a minute, this cotangent is one of my special right triangles, then you might find it easier to draw the triangle in the correct quadrants and get it that way. If we had, let me go ahead and show you if we had tried to do, since cotangent, is it sine over cosine or cosine over sine?
Cosine.
Okay, be cosine over sine. So here's what we could do. With sine, it would be a holla. Okay, and what I would look for is where would I get a ratio of -1. So if this is high, that's got to be a +1, but an axis is 0. So that one wouldn't work. Okay. This one would be 0 over 1, so that's going to be 0. In fact, all of these are either going to be 0 or undefined. So actually, because this ratio was a -1, it's not going to help us to do holla and a holla. I think you really would need to go ahead and sketch the triangle, because notice we're at 135 and 315, and those aren't axis angles. This is just going to help us if we're on an axis. So I'm glad you asked that. All right, does that make sense? All right, let's try this one. 3 sine squared x minus sine of angle x minus 2 equals 0. And this is going to be over the interval from 0 to 2 pi. So instead of using degrees, we're going to work with radians on this one. So we'll need to make sure we give our answer back in radian form. Let me box that up because that was our answer. So this thing's already set equal to 0. And ideas about what we might need to try to do. Excellent, Elizabeth. You're right. We do need to factor. Now, don't let the fact that we've got signs in there, sine squared of x and sine of x, mess you up. If you need to, think of the sine squared of x as being like an x squared. If this had been 3x squared minus x minus 2 equals 0, would you have been able to factor it? Well, there's a couple of different ways you can factor it. If you try to use the AC method, My A times C is how much?
Negative.
Negative 6. So if I'm looking for a pair of numbers that I multiply to get a negative, what do I know about the signs? Are they the same or are they different? They're different. So one's negative and one's positive. Now, my B value is what number? Negative 1. So is there a pair of numbers you can think of? Multiplies to give you negative 6, adds to give you negative 1. Well, the only things that are going to multiply to give me 6 are 1 times 6 or 2 times 3. Is there a pair that if I use one number as negative and one number as positive, it'll multiply to give me negative 6, it'll add to give me negative 1? There you go. Negative 3, positive 2. So if I were to factor this, okay, I could replace this minus 1x with a minus 3x plus 2x and go. This is exactly what we're doing here. The only difference is instead of seeing x squared and x, we're going to see sine squared of x and sine of x. Does that make sense? So I'm going to come over here. I'm going to keep my 3 sine squared of x, but I'm going to replace minus 1 sine of x with minus 3 sine of x plus 2 sine of x, and then have my minus 2 at the end. Well, if I combine these two, I'll be right back where I started. So the point in doing this is to get it to where I can factor. This is using the AC method. Some of you may have said, hey, I'm just opening up 2 parentheses, and I'm going to play with this until I get it to work. And that's perfectly okay. If we do it this way, what we're doing is pulling out the GCF of each pair. What's the common factor here? I've got a 3. What else do I have that's in common? Sine of angle x. Okay. Now, in parentheses, what would this have to multiply by to give me 3 sine squared of angle x? I need another sine of angle x, don't I? Okay. And then 3 times the sine of angle x times what gives me minus 3 times the sine of angle x? Minus 1. Good. Okay, taking care of the first pair. Now I need my plus sign, and let's look at the second pair. What would be the GCF here? 2. And what would need to go in the parentheses? Sine of angle x minus 1. Good. And these match, which is what we want to have happen when we're trying to factor using the AC method. So I should have 2 parentheses now. When I get this factored, what goes inside one of them? Okay, I can put the new common factor, which is the sine of angle x minus 1. The other parentheses will have what? 3 sine of angle x plus 2. Very good. Now, how can I make sure I actually got this factored right? Use FOIL to check it. And that should give me back what I started with. It will, okay? Now that it's factored, what are we going to need to do? Remember, our goal is to solve for angle x. Set each one of these parentheses equal to 0. Good, Louisa. So the sine of angle x minus 1 equals 0. And 3 times the sine of angle x plus 2 is going to equal 0. Okay, let's work with this one. Now I need to do what? Add 1. I want to know where the sine of angle x equals 1. Now, because the ratio is 1, what does that tell me might be a good thing to use to find it? Aha. We've already written it out up here. So where would we have a ratio of 1?
90.
Okay, 90, which because we're going to be using radians, that's going to be pi over 2. Okay? And that's the only place, right? Because we're using a hollow to see that. There's only one place that it's going to have a value of 1 in that interval. Now, what would we do with this thing? Subtract 2. And I get 3 sine of angle x equals -2, and then do what? Divide by 3. Good. So the sine of angle X is equal to a -2/3. Now, that doesn't sound like a special right triangle, does it? So if it's not a special right triangle, how are we going to find what the angle measure would be? This is where we're going to need to do basically what I showed you here, okay? In order to get the angle measure, I want to take the arc of that angle measure on both sides because I want to find out what X is. So what I'm going to do is find the arc sine of the sine of X on this side. And if I take the arc sine on this side, I've got to take the arc sine on this side. Does that make sense? Because all I can do is go to the calculator and get an approximation for angle X. Now, when I go to the calculator, first of all, I better be sure I'm in what mode? Radians. So I'm going to turn it on. I'm going to double check my mode. And I'm glad I did because I was in degrees. So I'm going to turn it to radians. And I need to know the angle whose sine ratio is -2/3. So what buttons do I need to press to find that? Second sine, and then type in -2/3. Now, I have a -0.729. If I write that using the negative radians, I'm not in the interval between 0 and 2 pi. Okay? So how can I fix that? Well, first of all, if I were to add 2 pi to this, would it then give me the equivalent using a positive value? Does that make sense? Okay, so if I add 2 pi, and it'll automatically do the conversion for me, I've got 5.5535. Okay, now that's actually going to be in what quadrant? Do you know? Let's figure this out. I could change it back to degrees if I multiply by what? By 180 over pi. Okay, 318 degrees. That means I'm in quadrant 4. All right, and I do know that sine is negative in quadrant 4. Where else would sine be negative? So I'm going to need to figure out what this would be in quadrant 3, right? And so how am I going to figure that out? Think about it this way. Let's pick something like, let's look at a 30, 60, 90. Okay, so let's say if this was 30 degrees here, okay, then this would be a -1, this would be the square root of 3, and this would be a 2. And so if we were talking about the sine, and we wanted it to know where the sine is -1/2, that would be this angle right here, right? Okay, but would it also happen in the third quadrant? Yes? Okay. So trying to think if there's an easy way to explain how we're going to find what it is in the third quadrant. It would be a whole lot easier if we were working in degrees and we knew what this was. So let's let's do it this way, all right? If you guys were to take this 318.1896 degrees, okay, which is what this 5.5535 radian measure is, okay, in degrees, then that means we would have about a 41.8 degree angle, right? And by the way, it won't be anything this hard on the test. So we would, yeah, so what we could do is figure out what it would be in degrees and then convert it back into radians. I'm going to tell you that there is one in quadrant 3. It would be 3.8713 in radians, but if you find this one and you found that one, I would be ecstatic. And you would have it, and on the test, you're not going to, remember, I try to give you harder things on homework than what you're going to see on the test. The factoring part, you could definitely see. The fact that this did not give us a special right triangle ratio made this part a little more complex. So these would be the values I would look for from you. The fact that this is written in decimal form is because it's in radians, and it wasn't one of those special angles, so we have to use, because remember, pi is about 3.14. So all it's done is make that conversion for us. All right, I know that was a little bit confusing, and we're kind of picking and choosing here. I'm going to skip some things, as in I'm going to skip this one, and I'm going to skip this one, and I'm going to tell you why. This thing won't factor. See, it's not set equal to 0. So I can't solve this unless I multiply this out and I move this over and set it equal to 0. And when I do that, it won't factor. I would have to use the quadratic equation formula. We're not going to do that, okay? This one is just a little bit on the messy side because of the values that are involved. I'm not going to give you one like that. So we'll just skip this page. Okay, but we will talk about strategies for solving these trig equations. All right, so first of all, when I look at it, I want to decide if what I have is linear or quadratic in form. Now tell me what that's actually saying. When I look at the equation, how would I decide if it's linear or if it's quadratic? What would indicate it's quadratic? It's got to be like sine squared of angle x or cotangent squared of angle x. If I don't have an exponent on my trig ratio, then it would be linear, okay? Now, if only one trig function is present, so in other words, if I only see one trig function with everything else, like this first one was, okay, then what I'm going to do is solve the equation for that function. In other words, we isolated until we had tangent of angle Q equals and everything else was on the other side. Now, if more than one trig function is present, we want to rewrite the equation so that one side will equal what?
0.
Perfect. Then, what do we try to do to the other side? Think of the F word. Factor. Good job. Okay. Then try to factor and apply the 0 factor property. Now, we're not going to do any of these on number 4, but it's going to state that if it's quadratic but not factorable, you would have to use the quadratic equation formula. And if you do that, you've got to check, because remember, you've got a plus or minus in there. So you'd have to check to see which of those solutions would be in the interval you're looking for. But we're not going to do one of those. And I'll double, before you guys start the homework, I'll double check. If I've got any of those in there, I'm going to take them out. And then the last thing would be try using identities to change the form of the equation. So if and we're going to look at an example of this in a minute. Megan, would you mind closing the door? Because sometimes we may find that if we were, like if there's a radical in there and what we're trying to solve for is under the radical, we might need to square each side of the equation to get started. If that happens, be sure you check for what we call extraneous solutions. Remember, if I square something, it can sometimes create potential solutions, but if I go back and I test them out, I may find not every potential solution it gave me is an actual solution. All right, and we'll look at some examples of this so you guys can kind of see. Now, look at this one. We've got 2 times the cosine of angle x over 2 minus the square root of 2 equals 0. We're going to try to solve this in the interval from 0 to 2 pi. We're not going to worry about the all solutions part. So how many trig functions do you see in there? So what do we want to try to do? Do we want to isolate for it? I think I would. So let's take 2 cosine angle x over 2. And how about if we add the square root of 2 to each side? Wouldn't it look like that? Okay, then what would we do? Can I divide both sides by 2? So now I have the cosine of angle x over 2 equals, and we can leave it as square root of 2 over 2 if you want. Or what would this have been before it was rationalized? Yeah, we might want to write it as 1 over the square root of 2, just because sometimes that makes cleaning things up a little easier in the long run. So you can either leave it that way or you can change it back to what it was before it was rationalized. Now, is there anything jumping out at you about what we probably ought to do here? Well, now be careful. This is saying the cosine of not angle x, but x divided by 2. That's different.
That's the half angle.
Perfect. That is a half angle identity that we're going to need. So the cosine of some angle divided by 2 has to be replaced with this. I need plus or minus, and the square root of 1 plus the cosine of the angle, which is going to be x, and then I put that over 2. Does that make sense? So I started off like we did on the very first one. I'm isolating for the trig function, but then when I got it isolated, I realized I had to use that half angle identity. And so I have replaced it with this. Now, that's kind of messy. What's something I might want to do in order to clean this thing up? Could I square both sides? Okay, so if I were to square both sides, let's see what happens. The square is going to do what to the square root? It's going to cancel out the square root. And does it matter if it was a positive square root or a negative square root? When it gets squared, does it just turn positive? It does. So this becomes 1 plus cosine of x over 2. In other words, what was under the radical is the only thing that's going to be left on this side, right? Equals, what do I get on this side? Say it again.
1 over 2.
You got it. Very good. Because I square the numerator and I square the denominator. And when I square the square root of 2, it just turns into 2. So 1 plus the cosine of angle x divided by 2 is equal to 1/2. Now, if the denominators are the same, what happens if I decide to multiply both sides by 2? They're going to cancel out anyway, okay? And I am solving 1 plus the cosine of angle x is equal to 1. I think I can do something with this. Where would I go now? Well, I don't have cosine squared, so I don't want the Pythagorean identity, but how many trig functions do you see? Only one. So what do I need to do? isolate it. Subtract 1 from each side, and that means the cosine of angle X should equal what? That doesn't look too bad. Now, how would I figure out what angle has a cosine ratio of 0? Hala, there you go. So hala means I've got what values? If this was 0, this is what? 90, or pi over 2. This would be 180. This would be 270. So I need to take 90 and 270 and write them in radian form. So angle X is going to be what? Now, what was said in the beginning that we've got to be careful, especially if we square both sides? Check for extraneous solutions. We need to see if both of these would actually work. How could we possibly check that out? You got to go back to the original equation and plug in. Okay, so let me show you how that would work out. So this is how you would check. And yes, you're going to get to use your calculator, but I want to write down so you can see how you do this check. I'm going to have 2 times the cosine of, since I'm saying X is pi over 2, what would pi over 2 divided by 2 turn into? Well, if I've got a fraction divided by another fraction, I do what? Leave change flip. So this is going to turn into pi over 2 times 1 over 2. So I'm actually looking for 2 times the cosine of pi over 4. Now, pi over 4 is one of my special triangles. That's a 45, 45, 90. So that's a 1, 1, square root of 2. What is the cosine in that triangle? It's going to be 1 over the square root of 2, right? I want to check and see if this thing is true. Now, I probably need to rationalize the 1 over square root of 2, don't you think? And 1 over square root of 2, if I multiply by the square root of 2 over the square root of 2, becomes what? 2 square root of 2 over, what's on the bottom now? 2. And what can happen with these 2's? Aha. Minus the square root of 2. Did that work? Okay, so here's what I know. This one is a solution. Now let's see what happens if we use 3 pi over 2. So 2 times the cosine of, we'll take 3 pi over 2. And since we've got to divide it by 2, we know that's the same thing as multiplying by 1/2. All right, so we're looking for the cosine of 3 pi over 4. Now what quadrant is that going to be in? 3 pi over 4. Well, pi over 4 was 45. 45 times 3 is 135. We're actually in which quadrant? Quadrant 2. So 3 pi over 4 is here. And that would give me, since that's a 45 degree in the second quadrant, this is a -1, that's a +1, and that's a square root of 2. So what do you end up with for the ratio of the cosine for this triangle? Bless you. -1 over the square root of 2, which we know rationalizes to be a negative square root of 2 over 2, right? I'm just kind of using some shortcuts because I've already worked with these numbers up here. It's just I have a different SIG in now. And I know these 2's cancel. What's a negative square root of 2 minus square root of 2? Does that give you 0? That does not work. So this is not a solution, only this one is. And I don't know it unless I check it out. Okay, now just to show you in the calculator. All right, remember we're in radian mode. So what we would have to do is 2 times, and we can put in the cosine of, and we'd still have to know what the angle needed to be. We'd have to do the cleanup part, but I can put in pi over 4 and then subtract the square root of 2 and see if it gives me 0. And it did. Okay? Does that make sense? All right, and then what would I do to check the other one? What would I have to change? Pi over 4 needs to turn into what? 3 pi over 4. So if I hit second enter, it'll pull all that back, and all I have to do is go back here to edit, and I can insert a 3 in front of the pi. So now when I hit enter, it did not give me 0. So you can use your calculator to do the check, but I want you to see you're probably going to have to put a little bit of work on paper to make sure you've got the right angle measure when you put it in. Okay? All right, questions so far? All right, I've got 2 more example problems I want to look at when we're done with 7-6. Question? Pretty good.
I'm good.
All right, we've got 8 minutes. Let's see if we can get it done. Equations with multiple angles. Okay, so this is going to be over the interval 0 to 2 pi. And we're supposed to solve the cosine of 2x equals the sine of angle x. All right. Anything you recognize here that may or may not be a problem? It's what?
Not equal to 0.
Well, it's not equal to 0, and how many different trig ratios do you see? 2. So you want to go ahead and set the thing equal to 0? You guys good with that? Nobody disagrees, right? Okay, so this would turn into cosine of 2x minus the sine of angle x equals 0 if I subtract sine of x from each side. Is there anything else that you kind of notice, maybe I need to deal with that? Say again. There is a double angle, correct? It's not the cosine of angle x, it's the cosine of 2 times angle x. So if I look at my double angle formulas, I've got a lot of options on how to replace cosine of 2 theta. Now, what do you think might be a good idea since my other term has sine in it? How about I use the one that only involves sines? Let's replace it with 1 minus 2 sine squared of theta. So this becomes 1 minus 2 times the sine squared of angle x minus the sine of angle x. Okay, what now? Yeah, in fact, I probably want to do a little rearranging, right? Okay, so which term should probably be written first? The one that involves the sine squared. So don't lose the sign, the SIGN that's in front of it. This is going to be a negative 2 sine squared of angle x minus sine of angle x plus 1 equals 0. But before I factor, I never want to factor with a negative sign in front of the first term. So what could I do to deal with that? I could factor out a negative 1, couldn't I? Because then if I factor out a negative 1, what would go in the parentheses? Negative 1 times what gives me this? 2 sine squared of angle x. Now what do I get? Negative times what gives me a negative sine x? I need a plus sine x. And then what goes here? Very good. By factoring out a negative 1, I change all of the signs from what they were. but that makes it a lot easier to factor. In fact, let me change these to brackets so we can see this is, the -1 isn't going to affect anything. This is the part that I need to factor. So to save a little time, I'm going to go ahead and open up 2 sets of parentheses. The only